In this video, we will learn about growing degree days. Growing degree days are a form of thermal time. The development of many crops and insects is driven by heat accumulation. In other words, these crops and insects only develop if there is adequate heat, and they will develop faster with more heat. If we know the minimum, maximum, and base temperatures for the growth of a plant or insect species, then we can use the daily minimum and maximum temperatures along with the growing degree day equation to predict the time to certain developmental events such as pollination or maturity in plants, as shown on the seed tag, and adult stage in insects. Using growing degree days to estimate and predict development is more accurate than using calendar days. You might be thinking, when do we start calculating these growing degree days? For plants, accumulation of growing degree days start once the corn is planted. For insects, we actually start accumulating growing degree days beginning January 1st every year. If you notice, there are no maximum and minimum growth temperatures for corn rootworm. We will go over an example problem of how to calculate insect growing degree days later in this video. The growing degree day equation involves finding the average temperature for the day, which is why we add the maximum and minimum temperature for the day and then divide by 2. An important step is remembering to check the boundaries of the temperature for each plant or insect before beginning this equation. Each species of plant and insect will have a specific set of minimum and maximum temperatures within which growth will occur. Outside this range of temperatures, growth and development will slower cease. When we calculate an average, it is an average of the temperature that contributed to growth and development. To ensure this, if the minimum or maximum temperature is below the range of temperatures, it should be replaced with the lowest number in the range, or the minimum temperature for growth. For example, in corn, the minimum temperature is 50 degrees Fahrenheit. If the minimum temperature for the day is 48 degrees Fahrenheit, then we would replace the 48 and use 50 degrees Fahrenheit in the equation instead. The same is true with the maximum number in the range. If the minimum or maximum temperature is above the range of temperatures, it should be replaced with the highest number in the range. Let's try an example problem so you can understand how the growing degree day equation works. If today's high temperature was 85 degrees and low temperature was 74 degrees, how many growing degree days would be accumulated for corn today? To begin this calculation, first we must begin by ensuring our high and low temperatures are within the acceptable range. In corn, this range is 50 degrees Fahrenheit and 86 degrees Fahrenheit, because corn will not grow below 50 degrees, and it will not grow any faster above 86 degrees. If either the high or low temperature for the day is below 50, that number will be replaced by 50. If either high or low temperature is above 86, that number will be replaced by 86. So let's try using our equation. Daily minimum temperature plus maximum temperature divided by 2, so we're finding the average temperature for the day that contributes to growth, minus the base temperature. Every crop and insect will have a specific base temperature to use for the growing degree day equation. In this example, 85 degrees and 74 degrees are both within the range of 50 degrees to 86 degrees, so we can proceed with entering the numbers into the equation. 74 is our low temperature for the day, and 85 is our high temperature for the day. Our base temperature in corn is always 50 degrees. So 74 plus 85 divided by 2 minus 50, and that gives us a total of 29.5 growing degree days. Let's try another example so we can see how accumulation of growing degree day works. Yesterday's high temperature was 67 degrees and low temperature was 48. Tomorrow's high temperature is expected to be 90 degrees and the low temperature is expected to be 82 degrees. What is the total accumulation of growing degree days over the 3-day period? Let's start by calculating yesterday's growing degree days. First, check the range. 67 is fine, but 48 is below our minimum temperature of 50. We will replace 48 with 50 and then continue on with our equation. So 50 for the minimum because it replaces 48, and 67 for the high temperature for the day. 50 plus 67 divided by 2 minus 50 gives us a total of 8.5 growing degree days accumulated for the day. If you remember, today's growing degree day accumulation was 29.5. Next, let's look at tomorrow's growing degree days. 82 is in the range, but 90 is not because it is higher than 86. We replace 90 with 86, and let's plug these numbers in. 82 is our daily low temperature, and 86 replaces 90 as our daily high temperature. So 82 plus 86 divided by 2 minus 50 gives us a total of 34 growing degree days that we expect to accumulate tomorrow. So our total accumulation for the 3 days is 8.5 plus 29.5 plus 34, total of 72 growing degree days accumulated over the 3-day period. Let's try an example with corn rootworm, since it's a little bit different than corn. So we're still going to use today's temperature, but if you notice, we don't have a minimum and maximum temperature. Let's plug our numbers into the equation like before. 74 degrees for the minimum and 85 degrees for the maximum. Our base is a little bit different this time because the base temperature for corn rootworm is 52 degrees Fahrenheit. So we'll have 52 for the base. 74 plus 85 divided by 2 minus 52 equals 27.5 growing degree days. Let's try another corn rootworm calculation, but with a lower temperature. So let's pretend that yesterday's temperature was a little bit lower than what we had calculated for corn. So now we're going to have a high temperature of 48 degrees and a low temperature of 42 degrees. So let's try using our equation. Daily minimum temperature plus maximum temperature divided by 2 minus the base temperature. So remember that we don't have a minimum temperature for corn rootworm growing degree days like we do for corn. So we will just insert the maximum and minimum temperatures as they are, 42 for the low temperature and 48 for the high temperature. Subtract 52 because that's our base when calculating growing degree days for corn rootworm. So 42 plus 48 divided by 2 equals 45, minus 52 for the base, and we get a total of -7 growing degree days. Is that right? Insects can't develop backwards or lose development they have already gained. Therefore, we can never have a negative amount of growing degree days. So instead of -7 for a growing degree day accumulation for the day, we will just have 0 growing degree days.